on pressure relief valves. Pressure relief valves are typically designed by using a spring. So imagine that you have a spring like this. So this is the original length of the spring. Very nice drawing. Now, to so assume that there is a flow coming from this pipe, and this ball is kind of stressed or compressed by this spring. So we compress this spring and kind of put it here like this. So it applies a force this way. You know that Hooke's law, Hooke's find out that the force is proportional to the compression of the spring. Now, if you take out that proportional sign, you get a constant that is called a spring constant. So this piece is a spring constant. Now, if you try to find the unit of that spring constant, you can solve for K, which then become F by X. So you can say in the US system, it's going to be pound per inch. Now, foot would be very large compression for a spring. In the international system, the force unit is Newton and the distance is meter, but meter would be huge. It's almost like 3.3 foot is 1 meter. So they use millimeter on the other hand. So Newton per millimeter. So that's the spring constant. So the amount of force that is applied. Now, here is one term that you need to kind of understand. This thing is known as initial compression. As you can see, initially the spring has to be compressed to apply that force. So that is called initial compression, which is, it's not, there is no standard for that. Let's say we use the amount is S. So the length or the compression amount is S as some X. You can say X either way. So force then equal to Kx. If we express the initial compression by S, it's going to be Ks. So that's the force applied here. Now, if we know the cross-section area of the pipe, which is blocked by this ball, so let's say that is A. So we can calculate the pressure here. So we can say if the force is applied F, the pressure would be then F by area, or you can say Ks by A, the pressure. Now, this pressure will just balance this force. So that's why it's called cracking pressure. It will not make any flow. It will just produce enough force just to balance this initial compression if you apply some pressure of this much. So that's why it's called cracking pressure. If you apply cracking pressure, there will be no flow, but this ball will be kind of floating. So just a little bit more, this ball will go up and it start to flow, which is in this picture. So the ball kind of went from this position. So this was the center. And then so I said the center was somewhere here. And then now it went there. So that would be the travel for that ball. Let's say it traveled X amount. So the force by that distance would be, so spring is even more compressed. So that force will be F equal to Ks, X. So the total force in this condition is going to be the initial compression force plus the additional compression to make full flow or kind of free flow, something like that. So that would be the total force. Now, if you want to calculate the pressure under this condition, it's the same thing. Pressure is equal to F by A. You can just say Ks, initial compression force, plus the additional compression force divided by the same area. This area is the area of the pipe, cross-section area of the pipe. So these are the equations you need, not really equation, basically the Hooke's law that we use for, be careful about these units. They're millimeter, inches, kind of messed up.